I wanted to go over the Ball AC, the Ball ADT. Um, I think some stuff had to be reviewed one more time. These two instance fields were added to the original. Um, this is the Boolean lonely that is actually used for when we have a ball, one constructor for the ball that doesn't take any input argument over here. If you look at this right here, so we say yes, it is lonely. But then we created um, another constructor that's called overloading, a constructor that takes an object of also ball type. And so it's not lonely. That's when we say that it's false. Um, let's take a look at, we have the accessor methods. In this case, I added the radius because I'm going to need it later on to check how close they get, those two balls. We're focusing right now on the ball driver because you're going to need to understand how these two balls interact to be able to do the second part too. Other things that require ADTs as instance fields. Then we have two set of methods that will be changing the velocity on the x component and the velocity on the y component. And I'm also changing the locations because I need to know for that video that I show you all the geometry behind all this. We need to know the distance between the two balls, the relative distance between the two balls, and how much do we want them to be separated. So we need to know the radius of it. Um, I ask you to add color to it, random color. So this was added to the original one. When there is when it's bouncing off the vertical wall and when it's bouncing off a horizontal wall. The move method is only, well, it's not only, but it has a piece of code right here that refers to the actual ball that is as the argument, which is using the second constructor in which the argument is again a ball. So here's the reason why we needed that set vx, set rx. Do we use it for here? Oh, not yet. I think we use it later. Yeah. So let's take a look at the second ball. We're looking at the distance between B1 and B2. This is actually coming from that video with the geometry behind it. So here is the distance between the two balls. We have the actual distance in the x coordinates between the two balls, or the difference between the two of them, and then a square, and the distance between the two y coordinates and square it. We add them together, and if we find the square root of it, then we get the hypotenuse. That's what we learn. But what is the diameter between the two of them? Actually, I should have called them radius, right? Both radius. Let me change that because it's not really the diameter. Use so the both radius together will add up to this. The radius is coming from the acting ball, the one that is actually that we create with the with this particular is the one that's acting, and then this is the one that is the input argument, and we call it a b, and so we need to get the radius from it. Now the distance between the difference between the distance or the length that connect the center of the two balls minus both radius together is this tiny distance that in the video we call it D, I believe. And so here we're going to say, well, how close do we want these two balls to be, the edges of the balls? In this case, we have 0.05, but you can change it to whatever you want. And then we call collision detection, or collision detected, actually. And we also change the colors. What's in the collision detected? Well, this is what it was in the original. We have a random behavior when they actually bounce off the walls. And then we also have random behavior when they're not lonely. They meaning that there are um, two walls. I think the original did not have random, right? I think it had negative Vx. Actually, I want to change that to negative Vx because um, that's changing in the opposite direction, right? There you go. And this one's negative Vy. I think that was the original. And that's pretty much it. Let's compile it. And then before we actually run the driver, there is an error here. Yes, look at me. I forgot the semicolon. We compile it. And we compile this. What's in the actual driver? Well, here is the first ball that we create, which is going to be, as you can see, the name of the object is B1, is going to be the input argument for the second ball. So the thing to learn from here is what I call in one of the videos overloading. So if I go back to the top, we can see the two constructors. And like I said in the videos, in the other ones, in this object B1, the constructor that is being called is the one that doesn't have any input argument right here. This is it. It's calling this constructor. Who calls it? Well, the new operator. In the second one, it's actually using the other constructor. Take a look. It's obvious that it needs a ball as an argument. And here it is. This is the one. What happens in the loop over here? Well, I shrink the canvas so the scale so the actual balls get to actually collide. Otherwise, we have to wait until they encounter each other. So all we do is just move the two balls and draw them and show, and there is a pose in there. That's pretty much all it is. So the only difference with the original is that I took B1 and I put it as an argument for B2. Okay, let's run it and see what we get. There we go. And well, that is stuck together inside that. Yeah, that is the reason why they behave that way is because, let's see, this condition, I'm looking at the wrong one. Yeah, since I made the scale smaller, hold on a minute. I should have made this smaller too. Instead of being, I'm gonna make it less than 0.02. Let me stop this. Let's see if we get less of that bizarre behavior. There we go. And see if that, now they're only going to bounce and escape that quickly. Okay, let's see if that's true. There you go. As you can see, they are bouncing off the walls the way you expect it to be. It's only when they collide with each other that I would like it to have bizarre behavior. Although that was pretty good. Anyways, that's the whole idea behind this part of the assignment. Uh, Originally, I had asked you to have the walls to have different colors. But the way standard draw is implemented is not allowing me to do that. This is that sticking together is because the change in the speed and the velocity is probably smaller than zero point 0.2. Remember, velocity goes from uh, 0 point negative number to a positive. Somewhere in there, it could become a zero or very small, so it will not escape that range that we put it um, as the distance between the two of them. There you go. You see it. Mm. So that is what I wanted. This will be the last um, video for the ball driver because I really would like to move on. There's a whole bunch of cool stuff coming up, and I don't want you to miss it out. If this is not good enough for you to really finally grasp what's going on, um, well, I'm available all the time to answer questions. I can chat. I can use Zoom. We can have actually a video call. Or just keep on emailing. There you go. All right, that was interesting. They don't want to separate. Okay, talk to you soon.